although actually what we could do, okay, I just had a better idea of how we're going to solve this.
So today we're making this water treatment pond, which I intend to use for a particular scenario for Fallout Wasteland Warfare that involves a water treatment plant. Although, given how tall it is, it's actually taller than a Chaos Vindicator, so it makes some great general line of sight blocking terrain. So, before we get into that though, a quick word from our sponsors, which is me and you if you're on our Patreon. So shameless self-plug there, link in the down there part if you want the STL for this thing or anything else we've made recently. Otherwise, it is also going to be available at ordnancewargaming.com.au once it's been on our Patreon for 3 months. So check out those places in the links below, or don't, whatever, it's a free country. But for now, let's get into it.
Okay, so looking at the reference images, there's a couple of elements we're going to need for our aeration pond. So we're going to need water, and I think I have an idea for that we will get to. There's going to be a couple of circles cut into the cylinders, or more donut shapes, I suppose. There is a fence around it. I don't know if I'll add that. I'll decide that later. Most importantly, there's a catwalk going across into the middle, and I think if we also put a pipe up over the top where the water comes in, that'd look pretty mad. Also got to figure out how to do a bit of a white water effect where it comes over this little ledge here and drops into the lower section of the pond. So let's get started. I have some ideas. So the first thing we're going to do is we're going to just generally just make a cylinder that's hollowed out in the middle to start with. Then we'll have this bit kind of rise up and we'll bring in our catwalk over the top. So let's get started. Okay, so I've brought in the industrial catwalk that we're going to be using over the top of this, and I've decided that even at a diameter of 190 millimeter, the biggest diameter I can fit in my printer, it's not big enough for the scale that we're after. So we're going to have to print it in 2 pieces to get the scaling correct, I suppose. So what we're going to do for that is we'll build it as though it's 1 piece, and then we will use a Boolean operation to cut it in half and create 2 different pieces that will have to be printed separately. Because if we try to make each piece separately when we put the texture in for the water, it's not going to line up and it's going to look a bit weird. A line cut straight across the middle we can handle after it's printed relatively easily. Having the texture not line up, that we can't really fix easily. So I'm going to double the size of this. Okay, so for this next bit, this little legs piece, we're just basically going to strip out all the faces on this side, mirror it, get rid of the cutout in here to just have it Boolean in there, because we want that to join on to be a part of that, so that there's a support midway into the pond. Then we can add the next section. So I've made this handrail 1 piece now, so that's good. However, the length of this catwalk is actually longer than what we can fit in our printer for the way this is going to be, because we're going to cut it in half straight down there. And this is currently going past the halfway point, which is just not going to work. So we're going to have to, I think we'll just take a segment off of here and just shift the whole thing back to get it to fit a bit nicer. I just got rid of the extra bit of deck that I brought in alongside this, the end bit of the handrail, and just used the 151mm length of the just straight piece of deck that we used from the industrial catwalk. I also filled in these so that, because this will all be booleaned together, it does not need to be modular there. I'm going to leave this little gap here and let it boolean together. That will add a nice little bit of detail there, which I think will work quite well. We'll bring in the bolts that hold it all together later. But so far, I think that's the catwalk out into the pond done. And for actual games, we can put a little computer terminal or something there. Whatever you like. Okay, so for the water that will be in this, I think we make it so that the water level is slightly below the edge of this inner tank. Otherwise, we have to have it run off and down here, and that could get a bit tricky. And the water level down here we want to be kind of low. So what we're going to do is we're going to scream internally. 1 hour later. Yeah, so what we're going to do is we're going to inset this a bit, drop this level down. This level down in the bottom bit will probably bring up a bit, and then we'll put them into two groups to have a subsurf applied to, as well as have our texture applied straight to it. And for the texture, I've got a sand texture that I've used, but I think if we apply a second subsurface division, just a one multiple one in for after the texture has been applied, that'll smooth out any grit that it will have and give us a nice smooth wavy, like watery texture. So let's do that and see how it goes. We've now got a watery kind of texture. So as you can see, if we zoom in just a little bit, it's a very subtle texture, especially on the top, because that's mostly smooth water. Down the bottom, there's a bit more turbulence because there'll be a pipe pulling the water out. And as you can see, it looks very smooth. If I turn off the second subsurf, it looks a lot less smooth and a bit more jaggedy. The second subsurface then smooths out any rough parts of that sandy texture, making it a water texture. So now I suppose we probably need a concrete texture for the concrete sections. Conveniently, I already have one. So we will go and set up the vert groups for that and apply the concrete texture. There we go. We now have a little concrete pond in the middle, little bit where it could flow down if the water level was high enough. And I mean, after you print this, if you want to have one that does flow down, you could always use water effects to have it flow down. This just means you don't have to if you don't want to. Little concrete out a bit to catch that water. The only thing that I think it needs now is a pipe, because how is the water getting in and how is the water getting out? So we're going to need to make some pipes so that we can do that, I suppose. The next day. Okay, so I've had another look back at our reference images, and I noticed that the little tab things here on our reference images, there's supposed to be these, are actually metal sticking up out of it. So we need to fix this a little bit. So I think the plan is knock all of these off first of all, and then we'll inset each of the quads that these were coming up out of, and then we'll extrude out from the inset part of that quad and see how that goes. Wow, there are some weird janky things going on with this. And we won't apply the texture to the bit sticking up, obviously. So let's do that and see how it goes. Okay, I think I know how we're going to do this. So I think we'll have little pipes going down into the bit right at the edge, and we'll have a pipe running right around the exterior of it. So a pipe that runs right around here with little pipes periodically going down like they're sucking this water up and out. And then I think probably, yeah, off it, we'll do a couple of variants of this. That's what we'll do. We'll have a pipe that kind of just goes straight through the middle of the wall and just goes into the center chamber there, so that that's where it can go. And it's the pipe coming through here. We'll be putting water into the middle, and then the little pipes around here, we'll be pulling it up, and there'll be another like a T junction pipe here, grabbing that water. Although actually, I think that will probably need to be over this side. So I think, yeah, our pipes come in and out here is the plan. So let's do that and see what we can do. I have no idea what I'm doing. There we go. We now have our pipe running around the perimeter with its little draw tubes to pull the fluid up. I think that works pretty well, except the subsurf needs to go after the mirror to get rid of that bit of weirdness there. I'll do one clipping on. So, something I just thought of while I was doing this is that all of these, this pipe should probably be a larger diameter than these draw pipes. So, I do I want this to go bigger than 6 mil? I think so. I reckon we're going to have to take this pipe up to 8 mil, maybe even 10. So, to do that without having to start again, I'm just going to go and scale out each of the loops in it by 33 by a third, so that we get 8 mil, because a third of 6 is 2. And if we add 2 to 6, we get 8. Maths, it works. Yeah, I think the pipe needs to go a little bit bigger, so we are going to go out to 10 mil diameter on the pipe. And to do this, since we're currently at 8 mil diameter on the pipe, if we just go to a scale of 1.25 on each of the verts, that should do the trick. Yep, that's looking much better at that size. Still looks a little bit weird where these join together, mainly because there's a little crease there. So we'll just need to bring them all in towards the center a little bit to get that to resolve. That's not ideal at all. So we're just going to do this by hand and get it as close as we can. And we'll just do what we can. Our other option is to apply the mirror and scale them all in just a little bit. It shouldn't affect the diameter of the pipe, and given this pipe doesn't connect anything to it, it doesn't matter that much. So I think that's what we'll actually do. We'll apply that, and then we'll go in, we'll select all of them, and then just scale them in towards the center a little bit. There we go. That's got those in there, and I think that works pretty well. Now, the next stages that we're going to need will be, obviously, this would not be manufactured as one large piece. That would be ridiculous. These would all be bolted together in shorter sections. So we'll need to put a disc kind of coming out from here on each side of where the pipe is. And this would be like a little T-junction that would be manufactured separately from the pipe, and this pipe would be bent. So that's our next step. And on one of them, probably this one down here, there will be a cross junction, because that will be the outlet of our pipe where it connects into the rest of the pipe network. So this bit here, I want a bit of an extrusion out from the pipe around here, and also around here. So I think that's still a nice circle. So I think we will still use that circle for where it comes out. And yeah, so basically what we're going to do is we're going to put, actually no, we are going to have to remove that and collapse that down for the circles to work the way I want them to. That's annoying, but that's fine. So we're going to take these pipes out and then collapse these verts in so that this ring is nice again. We're going to add 2 control loops into these spaces here between these 2 rings, and do the same on the opposite side. And we're going to put them on top of each other, the distance out from here where we want our joining plate to be. And then there'll be bolts that go through to make it look like it's joined together. So let's do that and see how it goes. So for the T-junction bit, we're going to use a 8-sided shape again. And it's going to start at the 10 mil diameter of this pipe, and then it's going to taper down to a 6 mil, and then have the joint and then the curve. Because if you look at proper pipes carrying fluids, you don't want harsh transitions between pipe size. You want it to be tapered. So that's what we're going to do. I think I have an idea for how I'm going to get this taper to work. So yeah, we're going to grab this exact circle, rotate it 9 degrees, and then get it to be the size that we need it to be. Okay, so for the bendy bit, there's 2 ways we could go about doing it. Option 1 is we could bring in a torus the same way that we did for these bendy bits. Option 2 is that we just extrude out and rotate this around, which I think is probably going to be the easiest way, so that's what we're going to do. There we go, it's not a perfect bend, but at this scale, it's perfectly acceptable. So now we just need to extrude that straight down till it penetrates into here. Whoop. Let's put a cap on the end. Bring a control loop down. And I think that is almost exactly how we want it. That bend looks nice. It's relatively neat. We just need to add control loops. There we go, and that's how that would all bolt together. So now we're basically just going to copy that piece and we're going to put it in the other spots so that, and then stitch it in, and then delete this and do a mirror again. So let's do that. There we go. That's all fixed up now. So we can apply that mirror so that we actually have all the geometry physically in there. And we'll grab bolts from our catwalk project, link in the down there part or the card, if you want to see how we made those bolts, and we will just place them all in there. For this small bit, we'll need to scale it a bit, and then we'll use much the same process we did for this bit as for the collector tube coming off of each of these to make this into a cross junction, but we won't be scaling it down. Basically, we'll just yeah, put it of this side because this would be an output. And then we'll need an input pipe with these little bits as well. So let's go grab those bolts, throw them in, and do that, I suppose. Okay, so I made a little boo-boo. When I was spacing out these bolts, would have gotten much neater if I just copied it, moved it to the other side, and then duplicated both and just rotated around the center. Would have worked much better. So I'm going to redo the bolts for these two bits, and then we'll copy and paste this configuration of bolts for all the other connections. Okay, so for the bolts around here, I've changed my mind on how I want to distribute them to get them to distribute a bit more evenly. Now, instead of just trying to place them and eyeball it all around, I've got these two at the same height on either side, and then we'll use the same number of bolts here. So we'll have 5 above, 5 below for a total of 12 bolts. So let's do that. We can't use the same rotation method we used over here on the small pipe because this is not on the same plane as X because it's twisted slightly, which is kind of annoying, but we'll deal with it. Although actually what we could do, okay, I just had a better idea of how we're going to solve this. We're going to put these on the same plane so they're roughly the right distance from the center, and then we'll do our copy and rotate technique, and then we'll rotate the bunch of them to put them back on the right plane. For lining these up, it doesn't help that this circle is not the same thickness all the way around. Just because it's curved and we're working, it makes it very difficult. So it's only a slight curve, but it makes eyeballing it hard. But I think that's pretty on point there, and they're neatly distanced around. Possibly even move on wide also. We'll just nudge them back across a bit. There we go. Now we copy them over this side and then for everywhere else. So let's do that. There we go. Got our bolts all in place and nice and evenly distributed around each flange. That was the word I was looking for earlier, flange. And it goes and picks up our little pickup tubes. Now, the next thing at the moment, this thing's kind of just floating in mid-air. So what we really need is some kind of support structure to hold it up would be good. And I think the way we're going to do that is we'll just make another piece that basically has a domed top, well, not domed, but a curved top there. It comes down and just clips on there, and there'll be a little bit that insets like looks like it's sitting on like a rubber mount or something, because this is big enough that it would move quite a fair bit as it heats and cools. So having a little rubber mount there would make a lot of sense. So a little bit of detail inset into the little mount piece, and then we'll just bolt it on to the side here, with a bolt that looks like it would go through for each metal plate as it comes down over the wall. Is how I think we're going to do that. I like that idea. We've also got to get rid of these. Got to get rid of this and probably this because the pipe's going to come through here for feeding water into the center pond. But we're making progress. Okay, something I just remembered with these little T intersections here that we should probably fix up is where they come together. There should probably be a little bit of a divot in here, just so that it actually looks like it's two pieces pressed together. So we're just going to tab in, and this is really easy to fix because we're just going to put 3 control loops in, bring them close together, and then scale the middle one in, which will give us our divots. There we go. So now we've got little divots in there where the plates come together, where you put a little bit of Nuln Oil in there, just to highlight that, or not highlight, shadow it. Shadow it, I suppose, would be the correct term. And I moved the bolts a bit because some of them were pressing out once I put that divot in there. Need to get rid of this bit in the middle, as there wouldn't be one here because it's currently clipping through the catwalk, which we don't want. So we're just going to get rid of this one altogether, which is why we're going to have this as the output of this collection piece. So we'll get rid of this bit, and these will just plate off to block off those ends. Okay, so for the bit up here, because this is directly across from where the catwalk is, so what I want here is for a pipe to come straight across to come into the middle for where it would be pumping water into this center reservoir. And also we want an output here for where the water would be getting pumped out of here from. So because there'll be a pipe coming across here, this pipe will go, which means this connection is not needed, but it is needed on the other side. So we'll probably just grab its verts and flip them around onto the other side. Should be fairly easy. And then we'll just have an output. We'll grab some bolts and put them in, and we'll see how it goes. Okay, so now we need to add our little magnet hole into here, which is 4 millimeters around and then 1 mil deep, but it actually needs to be 4.2 mil diameter, so there's a little room for glue and a bit more than a mil deep. So we're just going to bring in a circle with lots of verts so that we get the proper circumference, not circumference, diameter. And then we'll bring the one in with 8 while we've got the subsurface division on, and then scale it out to be about right. There we go, and now I've got our little hole the correct diameter. And the reason that we use the one with lots of verts to get the one with few verts to the right size, as you may have seen, once the subsurf goes on to the one with a few verts, it shaves off the corners, which actually reduces the diameter of the circle, which is, not ideal. So by doing it this way, that solves that problem. And we now have a nice little round 4.1 millimeter diameter hole for our magnet to go in for when the pipe clips on. So the only thing that this upper bit of pipe needs now is the bracing that we discussed earlier, or didn't discuss earlier, depending on how I edit this. But I think the plan for that is just a rectangle with a curved off top and then a little bit pressed in on each side, where that would be like a rubber bushing of some description to allow this to expand and shrink with heat. 1 hour later. Okay, attempt number 2 at the bracket is the first one that I tried. I absolutely hated. So I think I have a better way of trying to do this. So we're going to start with a cylinder, basically, which we're going to bring out to here. We have rotated this section 15 degrees just so we're working on a straight bit of pipe. We'll rotate it back to the final version, of course. We can start with a cylinder that's just going to go around the outside of this tube, and then we're going to have, it's going to be like a band of metal around the outside with bolts holding the top cap down, clamping it onto the bottom bit that will be bolted in. So we'll start by making a cylinder that goes around the outside, recess it in a bit for where there'd be like a rubber bushing type thing, and then we will just extrude it straight down to get a square piece that clamps onto the wall, I think. I think that's the plan. We're going to try it. And there we go. We now have our pipe bracketed, which is good. I set the bracketing up so that its origin was in the center, so I could just rotate it around nice and easily. Grab bolts, copy, rotate them correct amount of degrees, unless this is Nurgle. I mean, it is waste treatment, so maybe there's disease. For these end ones here, I added these because otherwise it has this whole section floating that looks a bit weird. So I just tucked it in, hid it in here. It's not perfect. I think I'd probably prefer it. I honestly don't know what a better way to do this would be. This is fine, I suppose. If I pulled this out a bit further, I'd have more room to put this in and probably look a bit less squeezed in there. But as it is, we're just going to have it squeezed in there. And if this was real and you actually had to take it apart, obviously you'd pop the cap off first, lift the pipe up, then you could undo these. It'd work, I suppose. Next thing that is needed is the pipe coming across here to feed water into the center pond. So I think for that, we're effectively just going to grab this bit here that comes off the end, and we're just going to extrude it out as a pipe that runs across and in, and try to keep it as simple as possible, because this has already got our magnet hole cut out in it, so it's the perfect part to just take and use. I think this outside bit will be fine once it's printed, and then the two pipes on their little stand is butted in up against here. That'll be fine, I think. It's really on the inside here where it comes through, bends down, and then comes in and across that we need to fix. So I'm just trying to think what our options are. Bracketing it onto this wall shouldn't be too hard. We could do that fairly easily. Just take one of these brackets and rotate it basically, so that it goes into this wall, and then maybe the bottom bit bring it out and have some bolts running through. Okie dokie. So now we've got a little bracket thing here holding this pipe onto the wall, which distracts a bit from the mess of it just punching through. And I think at this scale, that will be fine, because there's not really much else we could do around here with that texture, that won't just cause more problems for us elsewhere. So I'm fairly happy with that. We've got brackets, so it's mounted on here. It's added a little bit more detail down here, which is nice as well. So I think it's pretty good there. It's holding it where it turns, so yeah, I'm fairly happy with that. The last thing I think this thing needs, and I've been debating with myself a little bit about it, is do I think that the pond needs like little sprinklers sticking up just out of the water? I'm thinking probably not, to be honest. So while I think about that, we're going to work on how we fit this thing in the damn printer. And to do that, we're going to cut it into quarters, where we're going to make a shape that encompasses a quarter of it with some little notches sticking out and then sticking in around like 90 degrees. In here somewhere, probably try to line them up in the outer wall as well where possible, so that we can cut it into quarters and there'll be little aligning notches to align it. So for that, we're basically just going to use a cube with its origin right in the middle, so we can just rotate it around for creating the 4 different STLs that we're going to use. So what we have here is a box that encompasses the entirety of a quarter of the pond, with some little bits sticking out and some bits sticking in. So what the plan is for producing the STLs is, once we've applied the Boolean addition to join all of this into the pond to make it all one piece, we'll then do another Boolean operation. Which one? One of them. I just got to remember what it is. Intersect. A Boolean intersect. So once we've done the Boolean union to join it all together, we'll do a Boolean intersect with this cube, and it will basically give us a shape that includes everything from this that's inside this cube. And what that will do is it will give us a quarter of the pond with everything added in, with these bits sticking out. They've got to taper down so that when it prints, they'll slot in nice and neatly to these, because as we rotate this cube around, so 90 degrees, it's now over here. They're sticking out here into these slots here, 180 degrees around there, and so on. And that will allow us to produce our 4 quarters that will fit into our printer. I hope. That's the plan, at least. However, I don't want this going over this section, so we're actually going to start at 45 degrees, which will put the slice right on the center of these connectors. I've gone and produced the STLs, processed them out into little chunks like this, and they're not little chunks at all, they're massive. I mean, this piece, does it say anywhere how big this thing is? It's huge. It only just barely fits on the build plate, which we knew, but I forgot something very important, which is it's going to need supports to be able to be printed. So, I've already created these STLs, so these are now going to be marked as large, but I really don't want to print them this big. The other thing is, to print this whole thing, we'll use about 2.5 kilos of resin, which, 160 Australian micro pesos. I don't want to use that much. It's a bit large. These particular files will be available if people want to print really big ones, but I want the option to be able to do a slightly smaller one. So I was looking at my ruler here, and I was thinking the length of this would be almost perfect, and it would be cutting, like, what would that be? 90 mil off or something. If we cut it down to 300 mil across, each piece will then be 150 mil across, which will fit on the build plate much nicer. So we'll get out of Chitu box and back into Blender. Yes, our whole thing's a 380, so we'll be cutting about 80 mil off. So I've removed all of the booleans, and by remove them I mean done them so they're not active, so we can actually change this thing. And we can't just take each file and shrink it down, because this catwalk needs to stay constant, and these connections for the pipes need to stay constant. So what we're going to do instead is we're going to grab each individual bit. Part of the process of being able to actually produce the STLs without having Blender crash was I had to make all of these bolts one object. Actually, that's a lie. I didn't have to make all the bolts one object. I needed to remove the 2x subsurface division from each of them. I think even without subsurf, I don't think they'll print any different because they're very, very small. But I had to remove it from each of them. I didn't feel like going through 600 bolts and removing it from each one individually. So I made them all one object, just to make that a little bit easier. But the convenient part of that is that I can now just select that one object with its origin at 0 and just shrink it in. So we're going to go and grab each individual element, except for the catwalk and except for the little bolt bits here. And we're going to shrink them down. Not bolt bits, the bits of pipe that connect, because we still want that flange to be the same so it can connect into the modular pipes that we're going to make as well. So let's do that. There we go. And now we have a pond that is 300 millimeters across, or 299, close enough. Actually, what is it? 299 point. That's close enough. That'll do just fine. Which we can then slice using our cube into STLs, and we'll see how these ones go with printing. Except that's what I would say if there wasn't one more thing we needed to do, because we need to make sure that these pins are now in position where they can actually join this together. There we go. And now those aligning pins will line up in the new geometry. So we'll now cut out STLs, see how that goes in Chitu box when we slice it up and try and print it.
So, after some testing, we found a couple of small problems, mainly around this bit. The first problem is that it actually failed, and I can't get this bit to print properly, which is not ideal, and I think I know why. So when I have this thing in the machine, it's up like this with the build plate down here, and there's a whole bunch of support on this bit, and they're very long supports, so they don't sit straight properly, which is causing issues. Also had a bit of delamination up here, but I think I've solved that. That was more due to the drainage holes not being big enough, causing too much weight to be on that bit as it was lifted out of the vat. But the main problem still is this catwalk here. So what we're going to do is we are going to detach it so it can be printed separately. The supports for it are still going to be built into the main bit of the pond, but the catwalk itself will be detached. So to do that, I have already taken the liberty of turning off some of the Boolean operations so we can move stuff around. So what we're going to do is we're going to grab the legs and all of the bolts, and we're going to move them over to Pond Edition so they're attached into there. We're then going to have it so that the top bit is attached into the catwalk, so we'll separate that off, similar to how we did with the corner legs on the catwalk of the corner bit that we did the other month. And then this catwalk will just be able to slot on top of these legs built into here still. So let's do that. Okay, so we now have our little peg that goes into there, which is being added into the pond section. So now we need to finish up the receptacle for it, fix up these bolts, and we'll have to do that on both sides annoyingly, but we might just fix one and then copy it around and delete the rest. That's probably what we'll do. So that this catwalk can then be printed separately because it's not attached here. We'll also remove these legs and we'll bring in the STL file for the legs that clip onto the end of the catwalk from our catwalk project. Why remake something we can just reuse? And something I just noticed as well, where these supports go in, they'll need to be pulled back a little bit as well. Conveniently, that's very easy to do. Alright, maybe it's not easy to do because they join right onto the end. We'll have to fix that up. So we'll fix that, get rid of that, and finish off the receptacle in there, and then we'll re-export it, and that will be done. Okay, here's the plan for how we're going to fix this. Rather than, cutting it off, moving it back and all that, what we're going to do instead, so we're just going to extend this out a bit, so it has room for the supports to clip on, and then we'll slide this whole section back rather than trying to cut and do other stuff that's a pain in the butt. Just like that, makes it a bit easier. This bit's a bit bent in there, but it's under there. It'll be fine. It'll be hardly noticeable, except for people who've watched this far in the video, which means only people who actually care will know. Wait, that doesn't sound like a good thing. Anyway, there we go. That catwalk can now be detached, which will make that bit easier to print. Now, one other problem that we need to fix was when the two bits would clip together. Yes, here we go. When they come together, getting them, first of all, it has warped a bit, but that's easy enough to fix. It bends back down into place. Getting them to actually press in so there's no seam doesn't really work well, because I made a little bit of an oversight. I made it so the tips of the pegs are shrunk down, but the receptacle for the pegs is the same size as the base of the pin, so it doesn't fit. So what we're going to have to do is make it so that the receptacle side of our cutter is a little bit bigger so that it slots together nicely. Which, for that, all we have to do is, here's the receptacles. We just need to go and make the outer bit of these squares just, 0.1 of a millimeter bigger, so there's a bit of clearance there. So I took the difference in height between the base and the tip of the peg, which was 0.4 of a millimeter, and I expanded each of these out by 0.4 to have a 0.4 mil gap at the top, same as we have down at the bottom of the peg hole. Which means now, when we cut out the STLs for, I think this is the 4th time now, and print them, they will clip together nicely. They'll be much easier to print because that catwalk is detached, and hopefully this is the last revision. So let's do some testing, and, well, either we'll have, a conclusion now, where I'll have the finished product, or we'll be back for more editing. There we go. I've printed it out and stuck it together. Still need to fill the gaps before we, paint it and whatnot, but it goes together just fine. So I'm pretty happy with that and don't feel any need to change anything else about it. So, it did take a little bit longer than expected. Printing it was not easy to do. There were some very long supports that were just unfortunately unavoidable. If my printer was bigger on the X and Y axis, then I could have laid it down flat and it would have been so much easier. But these are the tools that we are working with, so we just got to do what we can do. Got there in the end. So I think the next bit we need to work on is some pipes to come out of the little pipe bits that we put on here. So that's what we're doing for the next month, I suppose. And of course, if you want this STL, it is now available on our Patreon link in the down there part, unless you're watching this in the future sometime, in which case it'll be available at our website, ordnancewargaming.com.au, link also down there. So like the subscribe button and smash the hit button, and we'll see you next time.